Just so you know what we're talking about here. It might apply to you guys. It strongly might apply to you guys. How's that sound? Yes, I am. So if I give you something like this with a right angle in it, and I ask you, what is the sine of angle A? So if this is angle A right here, sine is what? Opposite over hypotenuse. So if that's angle A, that's opposite. Of course, 13 is always the hypotenuse, right? The 5 would be adjacent for that. So sine opposite over hypotenuse would be 12 over 13. Very good. What if I ask you for the cosine B? Here's B. Now, if from angle B, this would be the opposite side, and this would be the adjacent. Well, remember, cosine is adjacent over hypotenuse, right? 12 over 13. How about the tangent of angle A? Tangent's opposite over adjacent. Which one's opposite now if we're looking at angle A? The 12 over the 5. How's about secant of angle B? It's number 12. For B, remember it's hypotenuse over adjacent, so the adjacent is the 12. 5, cotangent of angle B. Adjacent is B, so it's adjacent is the 12. And 6, cosecant of angle A. Hypotenuse is 13 over which one? Over the 12, yes. For angle A, it's hypotenuse over opposite. And for A, the 12 is the opposite. What if I tell you that sine of theta is 0.4? Can you find the cosine of theta? Yes, you can. Because the sine of the angle squared plus the cosine of the angle squared has to equal 1 squared, or 1. So we have 0.4 squared plus that cosine squared equals 1. 0.4 squared is 0.16. Plus cosine squared equals 1. Then what? Got to subtract 0.16 first. So the cosine squared equals 0.84. Then we square root it. 0.916. We're just going to 0.916 now. That'll work for us. Now, once we have those two, we're off and running. What's the tangent of the angle? Tangent, remember, is sine over cosine, right? So 0.4 over 0.916. We'll just leave it like that. You know, I can trust you guys know how to divide it out. How about cotangent? Cosine over sine, or it could be the reciprocal of tangent. Either one, right? Either way, it's 0.916 over 0.4. How about secant theta? 1 over the cosine. So 1 over 0.916. Cosecant of theta? So we found all of those different trig functions just by being given the sign. So what if I tell you that a plus b equals 90 degrees? And I tell you that sine of a is 0.4 and cosine of a is 0.916. What if I ask you for the cosine of angle B? What's it going to be? 0.4, yeah. If A and B add up to 90, the sine of B equals the cosine of A. How about the sine of B? 0.916, yeah. The sine of B equals the cosine of A. How about the tangent of B? Tangent is sine over cosine, remember? Secant of B is 1 over the cosine, so that's the 1 over 0.4. But I have to make sure I find the sine and cosine of B first, find the tangent, secant, and all those others. That should be a big hint for you guys, by the way. Just saying. That last little section may be important for you guys. So, we started talking about right triangles. If we're given pieces of information, for example, now of course we're going to label them A, B, C. C is usually the right angle. The sides are labeled as the angle that they are across from. A, B, little a, little b, and little c. If I tell you that B is 40 degrees and that A is 18 feet, I need to find angle A, side little b, and side little c. How do I find those? Angle A should be easy. How do I find that? 90 minus 40 gives us 50 degrees. Because the triangle has to add up to 180. The right angle is 90, so that means the other two add up to 90. 40 plus 50 makes 90. So this has to be 50 degrees. How about B or C? Well, B is the sine, yes, if I'm using C. But I have this one, which is the adjacent side, right? That would give me C, cosine's adjacent hypotenuse, right? If I'm looking for B, I'm going to use the 40 degrees because that's the one I was given. I just want to stick with that. B would be the opposite side. This is the adjacent, so that's going to be a tangent. Is opposite over adjacent. So tangent of 40 equals B over 18. Since we're looking for a side, we make it a proportion. We put the trig function over 1, and we'll cross multiply and divide. So tangent of 40 times 18 divided by 1. That's just tangent of 40 times 18. Of course, dividing by 1 won't change anything. So we have 15.10. Yes, it would. Yes. Now to get C, I have a few options here. I can do a squared plus b squared equals c squared. That would work. Or I can do, this would be my adjacent side, c is the hypotenuse, that would be cosine. So cosine of 40 degrees equals my adjacent side of 18 over my hypotenuse of C. I do the same thing. Put my trig function over 1 and I will cross multiply and divide. 1 times 18 is 18 divided by the cosine of 40, giving us 23.50 feet. Not so bad. Let's do another example. So let's say we have this triangle, again, A, B, and A, B, C for the angles, little a, little b, little c. Let's tell you this time that little a is 21, little b is 28. Want to find side C and angles A and B. How would I find side C? There you got it. Square root of 21 squared plus 28 squared, which is going to give us 35. Any questions so far? How do I find one of my angles then? Well, you'll see is 90. How about A or B? Yeah, it is. How do I find A or B? I'm going to use the sides I was given, the 21 and the 28. Let's go for angle B here. If I'm looking at angle B, what two sides are those? The opposite would be the 28, adjacent would be the 21. So that is a tangent. So I plug in what I have. My angle is B, opposite's 28 and adjacent's 21. This time I'm not looking for a side. I'm looking for an angle. So how do I do that? Inverse tangent. So the tangent and inverse tangent cancel out. B is the inverse tangent of 28 over 21. That's all right. 53.13 is correct. How about angle A? How do you get that so quickly? Subtract from 90. There you go. You guys ever hear of something called the Theodolus? Theodolus. Also a theodolite is another name that's sometimes used for a little bit different version of it. You ever heard of a transit? Hopefully. No? A transit. What a transit is it's for leveling stuff. Yeah, laser transit is the most common now. They used to be optical. Exactly. And you read it off of that's off kind of a big stick. You put a stake in the ground that was marked like a tape measure and you read off the measurements and you get elevations off of it. The transit had to be perfectly level and it was set up to make it perfectly level. A Theodolus, you still have to get it perfectly level, but it has an additional thing. Instead of just being sitting flat like that, the scope actually sits, looks almost like a protractor that it sits on, and it has a pivot at the center of the arc of that protractor. So you can actually, what's that? You've seen them? Okay. There's an indicator here that indicates, of course, how far away from flat, from 90 degrees it goes once you have it leveled. So once you get it all leveled out, this should be set at 0 here. You can actually tilt it, and it'll tell you an angle of tilt. Does that make sense? Let's say Jasper here is trying to cut down a tree. Yeah, he likes cutting down trees. You'll never own a chainsaw. So he wants to know how tall this tree is. But there's no sun today, so he can't use the shadows like what we did before. So what he's going to do, he's going to use this little Theodolus. He's going to sight through it. He's got the Theodolus set at 5 feet high because that's as high as he can reach to look into it. He's not paying attention. It sights up to the top of the tree, and it gives that this angle is 29 degrees. Jasper also measures from the base of the Theodolus to the center of the trunk of the tree is 123 feet. How tall is the tree? Well, we need to first find our triangle. There's our right triangle right there. This is also 123 feet. This is not H. We're going to call that X. Why isn't that H? You got to add 5 feet to it to get H. You got it. But you're right. Somebody said tangent out there. Tangent's opposite over adjacent. Yes, it's going to be tangent to the 29 degrees. Opposite side is X. The adjacent is 123. So we're going to solve that. We're looking for a side, so we put the trig function over 1 and we'll cross multiply and divide. Tangent of 29. Make sure we close that parentheses times 123. We don't have to divide by 1. It doesn't change it. It's 6818. 68.18 feet. So the height of the tree is that plus 5. That's a decent sized tree. Jasper's gonna be on his way home tonight looking for trees. Okay, there are some applications in electronics that are very significant. In electronics, let's say you have inductors and capacitors mixed with resistors in a circuit. There's something called phase. So when you're looking at a current in a circuit, the current through a resistor is always in phase with the voltage source. So we consider that to be 0 degrees. That is the resistor. If you have an inductor, remember an inductor resists changes in current because of the magnetic flux. So that is always, the current flows quickly, but then it resists change. So that ends up being at 90 degrees. It trails. The current in the capacitor, well, the current flows quickly at first and then slows down. That actually would be 90 degrees ahead, but the capacitor would be down at 270 degrees or negative 90 degrees. So let's say that I have a circuit, and at this given point in the circuit, at t equals a, it doesn't matter what the time is, the current through the resistor is 50 milliamps. The current through the inductor is 120 milliamps. So what we want to find is the total current which is A total or I total, however you want to do it. I don't know why I put A for amperage, but it could be I, but you guys get the picture. And I want to know the phase angle. Well, I use this diagram here. The resistance is in this direction, that's going to be 50. The inductance is in this direction, that's 120. And what we can do with it is we actually make a rectangle. We connect the origin to the far corner of the rectangle. That line I just made there, I'm going to change the color just a little bit. In blue is the resulting current. How do I find the length of that line? Well, there you go. That's the right angle. This is 50 and 120. So that length, that's my total current, square root of 50 squared plus 120 squared, which is 130 amps, milliamps. Those are in milliamps, so that'll be in milliamps as well. So my magnitude, my total current, is 130 milliamps. Phase angle is this angle right here. How do I find that angle? I have opposite and adjacent, don't I? Tangent, you got it. So we're going to inverse tangent. Which one goes on top? Opposite. There we go. Inverse tangent of 120 over 50 gives us 67.38 degrees. So there is our total current and our phase angle. Okay, so back to this theodolite. What if, well, another thing that theodolite can do that's a little bit different than the trans. Actually, some of your transits have this ability too, is if you look at it from the top, you've got your scope running through it like this, and on top there are actually angles measured out. There'll be an indicator somewhere that's marked at 0 degrees, and then it's actually marked out in all your angles going around it, your degrees going around it, so you can actually set it up, line it up with something, and then rotate it to get angles. You look like you're in pain over there, Jasper. Sort of. So let's say you're building a house in a city, and you want to line up the house with, of course, the street and the sidewalk. So what you might do is you might set up your theodolite right here on the edge of the sidewalk and line it up down the edge of the sidewalk and set that as 0 degrees. Make sense? So we would locate one corner of the house. Let's say we want one corner of the house or the building, we'll just call it building, one corner of the building to be right there. We do some measurements here. We find that from the location of our theodolite, that ends up being 8 feet in this direction and 25 feet in that direction. What is the distance from our theodolite to that point? How do we find it? I'm going to call that point A. The distance is going to be the square root of 8 squared plus 25 squared, right? What'd you come up with? 26.25, we'll round it to feet. What's the angle right here from our 0 point? The angle was going to be the inverse tangent. From that angle, what's the opposite side? The 28, 25 or the 8? 25. So it'll be inverse tangent of 25 over 8, which is what? That sounds right. Yeah, 72.26, right? So we can use our theodolite to locate that point by aiming at that angle, 72.26 degrees, and measuring out 26.25 feet. Let's say we want the second corner of this building. Let's say this building is going to be 28 feet by 40 feet. Make sense? So we want the second corner of this building right there. We're going to call that point B. If I set this up here, what's this distance here going to be? Still 25. I want to keep it square with the sidewalk, right? So anyway, what's this distance here then? 48. Very good. The 8 feet we had before plus the 40. So the distance to point B is going to be the square root of 48 squared plus 25 squared, or 25 plus 48. Either way, what do we get there for distance? $54.12 sounds better than what I got. So we'll go with that. I hit multiply instead of add. So that's our distance. Our angle is again inverse tangent of what? So this is our angle now. What's the opposite side? Opposite side, this is our angle, so the opposite side will be up here. 25 over 48. Second tangent of 25 divided by 48. 27.51 works. Degrees. Let's call this corner point C. What is, well, this distance, of course, is still 48. What's this distance now? 53 feet. Very good. So if I'm connecting across here, what's the length of that green line? You're thinking angle. Perfect. 53 squared plus 48 squared, which is 5.1 if we round it up. Okay. 71.51 in our angle. Perfect. 53 over 48. Here's our angle right here. 53 is the opposite side, 48 is the adjacent. That gives us 47.83 degrees. Sounds good to me. Finally, we've got point D down here. What's this distance? That's back to being 8 feet. What's this distance here? 53. So the distance to point D is 8 squared. Yeah, square root of 8 squared plus 53 squared, which is 53.86 feet. Works for me. The angle, 60. Okay. The angle is the inverse tangent of. Now remember, the angle is right here. So the opposite side is really this up here, which is 53 over 8, which is going to give us 81.41 degrees. Very good. So you can actually use the Theodolus to find the corners of your building and get them exact, so you know you are perfectly lined up with that sidewalk. Other applications of that, you might have an existing house in your building or garage over here, and you want to make sure that they're sitting square with each other. So the same thing, you might set your Theodolus, right here and line it up with the edge of the house and set that as your 0-degree point. Or you could set your Theodolus off somewhere and you could scope each of the edges of the houses and figure out what your zero line is. But it's usually easier if you just move it around until you get it lined up perfectly with an edge and go off of that. Any questions? Well, you sight down it. What you do is you get to where you can see the far corner, and then here, you do like this. So you're looking at it, so you're seeing this far corner, and as you move this way, that corner gets closer and closer and closer to the near corner. The second that far corner gets to where you can't see it anymore, you're lined up perfectly. Does that make sense? Yeah. So I'm going to give you guys something to play with here quick. This is in the big book, page 734, exercise 34-3, page 737, 738, exercise 34-4. I realize I gave this to you guys last time, but I didn't give you any work time, so I'm going to give you a little work time. We'll discuss those a little bit.